In this video, I'm going to teach you how to solve the measures of position or the quartile, decile, and percentile of a group data. So let's say we have this table. This is a group data table. It's grouped according to the age, 10 to 12, 13 to 15, 16 to 18, 19 to 21, and 22 to 24. That's why it's called grouped data. And then we are going to find the Q1 or the first quartile. So first let's have the formula of the quartile. We have the Q sub K. K stands for the position among the four quartiles. First quartile, second, third, and fourth. And here's the general formula. Lower class boundary plus the Kn over 4. That's the actually formula for the quartile class. Minus the less than CF lower or the lower less than cumulative frequency divided by the frequency of the quartile class, and all of this multiplied by the class interval or class width. And so based on the formula we need the lower class boundary. So how to find the lower class boundary is subtract the lower limits by 0.5. So 10 minus 0.5, 9.5, 13 minus 0.5, 12.5, 16 minus 0.5 is 15.5, 19 minus 0.5 is 18.5, 22 minus 0.5 is 21.5. Then we also need the column for less than cumulative frequency. So how to do it? Copy the first frequency from the smallest group, 10 to 12. So copy it and then add with the next frequency. 5 plus 8, 13. 13 plus 5, 18. 18 plus 10, 28. 28 plus 2 is 30. The next is to find the quartile class. The quartile class is the row that we will use in order to substitute from the formula. So let's have the quartile class, which is equal to k times n divided by 4. So it's actually the same from the formula kn over 4. And n is the total frequency. And so we need to add the frequency. And this is equal to 30. So let's substitute. We have k is 1 because it's first quartile times 30 divided by 4. And this is equal to 7.5 or the 7.5th number. So we're going to find the 7.5 from the less than cumulative frequency. And it is actually in between 5 and 13. And we always choose the bigger number. Even if it's 5.01, since 5.01 is still bigger than 5, then we will go to 13. And so we will choose this row. So this is our quartile class, and these are the numbers that we're going to substitute to our formula, except for the less than CFL. So let's continue. This is equal to the lower class boundary is 12.5 plus we have the kn over 4, which is the quartile class, that is 7.5 minus the lower less than CF. Less than CF lower than 13 is 5, so we're gonna put 5. So it's not the one in the quartile class, but it's the one that is lower than that over the frequency of the quartile class, which is 8 times the class size 13, 14, 15. That means it's 3 numbers for every group, so times 3. Now, so let's continue. We're gonna solve first inside the parentheses. So it will be 7.5 minus 5, which is 2.5 over 8 times 3. And this is equal to, copy 12.5 plus, so 2.5 times 3 is 7.5 over 8. which is equal to divide 7.5 by 8. This is 0.9375. And then now we can have the final answer. The first quartile is equal to, which is just approximately because we will round up to two decimal places, 13.44. So the first quartile is 13.44. This means that 25% of the data is lesser than 13.44. So let's have the same example to find the third quartile. So same formula that we are going to use for the q sub k, where k now is 3. So we need the same columns, the lower class boundary. So of course it's the same given, so it's going to be the same lower class boundary as well as the less than cumulative frequency. And then we are going to find the quartile class, which is having this formula kn over 4 for quartile. And n is, of course, the total frequency is 30. So we're going to substitute k is 3 and n is 30 divided by 4. 3 times 30 divided by 4, it will be 22.5, which is the 22.5th number. That's what we are looking for. And we're going to look for 22.5th number from the less than cumulative frequency. So this number is in between 18 and 28. And we always choose the bigger number, which is 28. So we're going to use this row. And now we can substitute. Our lower class boundary is 18.5 plus kn over 4. The quartile class is 22.5 minus the the lower value, the lesser than cumulative frequency, which is 18, over the frequency of the quartile class, which is 10, times the class size, which is 3. That is 19, 20, and 21. That's 3. So let's continue. Let's solve the one inside the parentheses. 22.5 minus 18, that is 4.5. So copy the rest, which is equal to, so let's copy first and multiply 4.5 times 3, which is 13.5. So copy the 10. And 18.5 plus, so we're going to divide 13.5 and 10, which will be 1.35. And the third quartile is equal to 19.85 when you add 18.5 and 1.35. So this means 75%. Quartile 3 means 75%. 75% of the data is lesser than 19.85. So this is also means 75% of the participants are having an age of around 19.8, lesser than 19.85 years old. So that's the meaning of third quartile. So let's continue. Let's have the same example, and this time we're gonna find the fourth decile. So the fourth decile of this data, and let's have the formula of the decile. So we have d sub k. K stands for the position from 1 to 10 because it's decile, and it is equal to lower class boundary plus the kn over 10. That's the decile class. So it's over 10 now because it's decile, minus the lower less than cumulative frequency over the frequency of the decile class times the class size or class width. So let's have the column that we needed, which is the lower class boundary. So we have discussed the first the previous slides, and the less than cumulative frequency. So let's have the decile class. So this is equal to kn over 10. And we're gonna find the n. N is the total frequency, which is 30. So because it's the same example with the previous examples, so it's gonna be the same n, which is equal to the k is 4 and n is 30. divided by 10. So 4 times 30 is 120 divided by 10. It will be 12. So it's the 12th number. And we're going to find it in the less than cumulative frequency. So 12 is in between 5 and 13. So we're going to choose 13. It's not because it's closer to 13, but it's because it is the bigger number. Even if it's very, very close to 5, still we're going to choose 13 as long as it's in between 5 and 13. So we're going to use that row to substitute in the given formula. So lower class boundary is 12.5 plus the kn over 10, the decile class is 12, minus the lower less than CF, which is 5, over the frequency of the decile class, which is 8, times the class size, which is 3. So let's solve 12 minus 5. So copy the rest. It will be 7, and copy 8 and 3. Then let's continue. 12.5 plus 7 times 3 is 21 over 8. And copy. 21 divided by 8 is 2.625. And let's get the sum. So the fourth decile is approximately, because we will round off, 15.13. And that is the fourth decile. So this means that 40% of the data is lesser than 15.13, or 40% of the participants is having an age lesser than 15.13 years old. So we're gonna continue, and let's find that sixth decile of this data. So the same formula for the decile, although the k now is 6. And so let's have the first column lower class boundary, and the second column needed is less than cumulative frequency. And let's find the decile class, which is having this formula kn over 10 for decile, and n is, of course, that's total frequency of 30. So this is equal to, the k is 6 and n is 30 divided by 10. So 6 times 30 is 180 divided by 10 is 18. So we're going to find the 18th number. So based on the less than cumulative frequency, 18 is there. It's exactly 18. So that is now our row. So you don't need to decide which among the two numbers, because it's exact 18. As long as it's exact, we're going to choose that. But if there is a decimal, let's say 18.0001, even if it's just a very small difference, you're going to choose 28. You're going to choose the next number. So that's the rule for that. But since it's exactly 18, so we're going to choose that row. And then let's substitute. Lower class boundary is 15.5 plus the kn over 10, decile class is 18, minus less than less than cumulative frequency, which is lower than 18 is 13, over the frequency of the decile class, which is 5, times the class size is 3. Then let's continue. Let's copy 15.5 and plus. So 18 minus 13 is 5. So let's copy the rest. And then copy 15.5. Now you can actually divide 5 divided by 5. That's 1. And 1 times 3 is 3. But for the sake of being consistent, so we'll just be consistent with our procedure. So just times first 5 times 3. 15 divided by 5. So 15.5 plus 15 divided by 5 is 3. So the sixth decile is equal to 18.5. So this means 60% of the data is lesser than 18.5. Or for the based on the given, 60% of the participants are having less than 18.5 years of age. So now we're gonna find the 19th percentile of this data. So what's the formula for percentile? So we have P sub k is equal to the lower class boundary plus kn over 100 minus the lesser cumulative frequency over the frequency of the quartile class times the I, which is the class size. So it's over 100. So it's similar formulas for percentile, quartile, and decile, except for the divisor of Kn, which is 4 for a quartile, 10 for decile, and 100 for percentile. And so let's have now the columns, lower class boundary, and the less than cumulative frequency. And then we're gonna find the percentile class, the row that we needed to substitute in the formula. So this is equal to Kn over 100 because it's percentile. So and the total frequency is 30. And this is equal to K is 19 because it's the 19th percentile times 30 divided by 100. So 19 times 30 divided by 100, it will be 5.7. So we're going to find a 5.7 number. So we're going to look at the less than cumulative frequency. It is actually in between 5 and 13. So as I said, we're going to choose always the bigger number, not the closer one. So we're going to choose the 13. So now we are going to substitute. Lower class boundary is 12.5 plus the Kn over 100, the percentile class 5.7, minus the less than Cf, it's lower, which is 5, and the cumulative, the frequency of the percentile class, which is 8, times the class size, which is 3. So let's copy 12.5 and subtract 5.7 and 5, it will be zero point 0.7. So copy 8 and 3. So let's continue. Let's multiply zero point 0.7 times 3, 2.1 over 8, which is equal to 12.5 plus 2.1 divided by 8, 0.2625. And then we're going to get the sum. So we'll round up to 2 decimal places. So we'll just put approximately equal to 12.76. So this means 19% of the data is lesser than 12.76. So let's have our last example. It's actually the same table, but we're gonna find now 96th percentile. So we're gonna use the same formula for percentile, and we're gonna have the same lower class boundary and less than CF because we have the same table. And we're gonna find now the percentile class of the 96th percentile. So the formula Kn over 100, where n is equal to 30. So let's find now the 96th percentile. 96 times 30 over 100. So this is equal to 28.8. So we're going to find the 28.8 number. So from the less than cumulative frequency column, it's actually in between, it lies between 28 and 30. So always choose the bigger one. So we're going to use this row with a 30. And substitute. Lower class boundary is 21.5 plus Kn over 100 is 28.8 minus the lesser cumulative frequency, lower than that, is 28, and uh, frequency of the percentile class is 2 times the class width is at 3. Then copy 21.5 and we'll subtract 28.8 and 28, which is zero point 0.8 over 2 times 3. So equals 21.5 plus. So by the way, you might wonder why do we keep on multiplying before dividing? If are we violating the MDOS rule? So actually, we're literally violating it, but since we know that it even if we violate it, the value is still correct, and will avoid also um, it will avoid also some complications when the divisor is 3. So that's why just for this problem, just for this kind of solving, we're gonna multiply first before dividing, even if dividing comes first from the left, because as long as you, it will not result to a wrong answer, because sometimes when you violate the MDOS, it will give you a wrong value, but in this case it's not, so it's okay to do that. And as long as it helps you to avoid some complications, then you can do it. So 3 times zero point 0.8 is 2.4 divided by 2. So 21.5 plus, so half of 2.4 is 1.2. So the 96th percentile is um, 22.7. So this is saying that 96% of the participants is aging less than 22.7 years old, or 96% of the data is less than 22.7. So that's it. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.